Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you today, as it is every day, here in my virtual classroom. Step on aside as we jump into the section 2.1 to 2.4 quiz review in the Big Ideas Math Integrated Math 1 textbook. I really just want to kind of call it the 2.4 quiz review, because if you notice what 2.1 up to 2.4 have been doing, they've been leading all the way to this. And 2.4 technically asks questions that could have any part of 2.1 to 2.3 within it. I guess, sort of, kind of, maybe. Anyway, I believe it's 16 questions throughout. Should be kind of short. So far, this chapter has had really short sections or really short stuff to work on. The way that I graph inequalities may be a little short-sighted, just putting 0 and all that, but I'll talk about double checks and make sure we get this all going. So without further ado, guys, jump to the description section down below. You can find the PDF and find the timestamps for each individual problem I'm going to present to you for a quiz review. And let's go ahead and, get started right now. We have you know what I didn't do is give your little circle guy right here. We have numbers 1 and 2 where they're asking you to, let me make this go, there it is. Write the sentence as an inequality. Number 1, a number z minus 6 is greater than or equal to 11. So we're just writing out the inequality. So here's a number z, here's minus 6. Now greater than or equal to symbol has the mouth facing the side that it's supposed to be greater than, like that, or equal to looks like that, 11. The is greater than or equal to is the phrasing you're finding that separates the left expression from the right expression. Now, generally we call this side greater than anyway, regardless, or like the mouth going that way, but that's only when we're reading this left to right. If you read it right to left, it says 11 is less than or equal to z minus 6, which is true. But that's how we would write that one, and that's all they're asking you to do. On number 2, 12 is no more than the sum of negative 1.5 times a number w and 4. Okay, let's first talk about the expressions, then we'll get to the inequality itself. Well, let's first separate the expressions. Is no more than is where the inequality is placed. So 12 is on this side. On the other side is the sum of negative 1.5 times a number w and 4. So there's a sum that happens somewhere, a plus. They also mention there's a multiplication, negative 1.5 times a number w. So those two are multiplying together, but there's a sum of something and something else. The sum is of this and that. So negative 1.5 times a number w and 4 are summed together. And that's the other expression. Now it says 12 is no more than this, which means 12 can be equal to this or it can be less than this. And that's how we're going to state that. 12 is less than or equal to this because it can be no more than that. If it said it's greater than it, then you say, well, wait a second, you said it couldn't be more than it. Oh, right. Yeah, that's right. So if it can't be more than it, it can be less than it, it can be equal to it. There's the answer to number 2. Numbers 3 and 4, they're asking you to write an inequality that represents the graph. Now, in these cases, you can choose whatever variable you like. I would default to x personally for myself. I'm going to draw this in a kind of shortish way. This is what I would generally do. I would place 0 and, this problem actually has 0 as the boundary point. I'd place 0 on the number line and the boundary point. This time 0 is the boundary point, or boundary value. My boundary point will have an open circle and the graph is going to the left. These are all of our x values. They're asking what x values are these. Now, when you look at their number line, more detailed, they show x can be negative 1 or negative 2 or negative 3, negative 4, negative 5, and onward. It can be negative 0.5, negative pi, any negative number. So what can our x values be? We don't write a list. We write an inequality. We say the x values can be anything less than 0. Can x be 0? Based on the open circle? No. Open circle means it does not include the boundary point that it's on. X clearly can't be positive numbers, as you can see detailed from the set. So this is all still a part of section 2.1. We never solved any inequalities in 2.1. That started in 2.2. So this was just writing them, drawing them, things like that. So number 4, this is how you're going to see me draw answers when they ask you to sketch a graph of an inequality on a number line. I'm going to place 0 on there and the boundary value, such as 8 right here. And this time there is an 8 that is closed, which does mean that point is included. And my x's are now going this way. So in this case, 0 is not a part of the solution set. Neither is anything that's less than 8. 8 is the beginning of things that are part of the solution set. X can equal 8. X can also be, according to this, 9, 10, 11, 12, 1,000, a billion. Can't be pi. X can be anything greater than 8. X can be equal to 8. X can be greater than or equal to 8. Now, whenever we do this, because after this looks like we're going to solve. From here on out, before I graph my set, because they're going to say graph the solution, I'm going to place my variable on the left side of the inequality because it's best to compare your variable to your boundary point to state whether you're drawing your arrow to the right or left, not whether the boundary points to the right or left of what you're drawing. So when x is less than is left. Less than is left, and greater than is right. The equal to is when you include the point, you close the circle. Not equal to, they don't say that, but just less than, exclusively less than or greater than, open circle on that. Remember, this is a quiz review, right? We're coming up with how to prepare best for these. Numbers 5 through 10, they say solve the inequality, graph the solution. This is from sections 2.2 and 2.3 combined. Now, section 2.2 was on solving by addition and subtraction, properties of inequality, and 2.3 was solving using multiplication and division, properties of equality. So they really want to get these ones done in one step. 2.4 was when you had multi-step, which is why I say it's all kind of a 2.4 review, because technically they could have asked these out of 2.4. You're just solving for the inequality in your graphing. So with these ones, you're getting q by itself. It's no different than what you would do with an equation. 9 is being added with q. We'll subtract 9 from both sides. We'll get q by itself. I wanted q on this left side of the inequality. It is. And 15 minus 9 is 6. That's the solution to the inequality, and we're going to sketch its graph. What are values of q that are less than 6? Well, 0 is one of them. And 0 is to the left of 6, so anything to the left of 6 is going to go. But wait, Mr. Robinson, you didn't fill in the circle. Yes, that's true. We also have to fill in the circle because q can also be equal to 6. Here are all values of q that are less than 6. That includes 0. You can double check that by showing 9 plus 0, or 9, is less than or equal to 15. Remember, 6 can go in here. It doesn't have to be less than it. It can also be equal to it. Number 6. We have z minus negative 7 is less than 5. It's best that you simplify the subtracting negative and turn it into addition before you do any movement afterward. In general, you want to do simplification of a side, right? Subtracting a negative, I'd say, qualifies as that. Simplify the side. Now let's go ahead and move 7 over. Because it's added, you will subtract 7 from both sides like you did on number 5. 5 minus 7 is negative 2, and z is less than z negative 2. So on this number line, if I sketch a 0 here, negative 2 is already left of 0 in and of itself, and we have to go less than negative 2. So we're going to go to the further larger negatives. Larger negatives are lesser in value. They're further to the left there. So 0 wouldn't be a solution to this original inequality. If I plug 0 in, 0 minus negative 7 is 0 plus 7, which is 7. 7 less than 5 is not true, and it shouldn't be true for this scenario, so I trust what I have there. Assuming I have the right boundary value, and I do. That's correct. Now, number 7, we have subtraction this time when it comes to solving for y. It says negative 3 is less than y minus 4. I'm going to add 4 to both sides, and here we do get 1. Negative 3 plus 4 is 1. 1 is less than y. Now, you could graph it from this, but the problem is if you did, and I promise you I can intentionally trick students and go, haha, good, I'm going to make you get it wrong. I actually kind of hope some get it wrong to state, no, here's what it is, here's why it is. Don't just look at this less than and automatically think less than is left. Now 1 is less than y. 1 is your boundary value. 1 is to the left of all the y values you can be. That means the y values go to the right. Y values go to the right. See, check this out. I'm going to draw it wrong to begin with, and you'll know because I'm going to draw it in red. Here's 0, here's 1. We say open circle, which is fine there. That's not the wrong part, but less than. If we placed y here, that means 0 should be a part of our solution set. After all, 1 isn't less than 0. That doesn't actually work. But you plug in 0 here, it says negative 3 is less than negative 4. Also not true. Larger negatives are smaller than smaller negatives, right? So that's not a true statement at all. No, we don't go to the left. We go to the right. If we go to the right, then that means our inequality should probably be reflected as such. If I flip everything over in the inequality, literally, turn the y on this side, turn the 1 on this side, flip the inequality over, you get y is greater than 1. As I said, this is read left to right is less than, but right to left, it's y is greater than 1. So I would flip it this way and then do the drawing based on that. You can double check 0, all should be good. So that's why I was saying anytime I have a variable on the right side of the inequality, I'm going to move it to the left, ultimately. And there, among other things, there are times where, and we're going to talk about what happens when you have a negative coefficient or the trade-off versus having a negative coefficient on the left and having the positive inequality on the right, positive variable on the right. 3p is greater than or equal to 18. 3 is multiplied by p, just like equations. You can divide, both sides by 3 and solve for what values of p can make this thing possible. And remember, that's what we're doing, right? We're finding what values of p make this true. Does 0 work? Great. Or not, or whatever. Do other numbers work? Apparently, if I plug in any number that's 6 or greater than here, it'll make this inequality true. 7, 8, yeah, 3 times those are greater than 18. And 3 times 6 equals 18, and 3 times 5 is not greater than or equal to. So all the values that do work, let's shape that one up a little better. All the values that do work are 6 or greater. Anything less than or equal to 6 is no. And that's a good time to just make the statement here as well that every inequality solution that we have like this is an infinitely many solutions. Infinitely many. We're going to talk about special cases here, I'm sure. And when we do that, we have something that used to be like infinitely many solutions. It's actually called all real numbers now. Because these are all infinitely many solutions, right? Now this is 6 is greater than w over negative 2. And there are a lot of things I can say on this. I'll try and keep it short. For one, this is a division problem, which means as an equation would go, we would multiply both sides by negative 2. So in this case, I also want to multiply both sides by negative 2. It gets w by itself. Negative 2 over negative 2 is 1. Now negative 2 multiplies by 6 to get negative 12. And here's w on this side. Next thing is, we just multiplied both sides by a negative. Therefore, the inequality will flip. The inequality will go this direction. Not going to speak on why in the moment. That's more to do with the section. But whenever you multiply or divide both sides by a negative number, the inequality flips. Multiply or divide both sides by a negative number. Inequality flips. Third thing is w is on the right. I want to write it on the left and write it as w is greater than negative 12. Now you can double check this by once again plugging in 0. Notice that 0 should be a solution to this because negative 12 is left of 0, but we are graphing to the right of negative 12 to represent w. That includes 0. Does this work? Now 0 is great to substitute for products and 0 is great to substitute for any of these problems because 0 wipes out products and quotients. 0 over negative 2 is 0, right? And like y or 0 minus 4 is just negative 4. It's great that it kind of just goes away on its own based on what we do. So is 6 greater than 0? Yes, it is. That makes a true statement. I expected a true statement out of it. 0 is a part of our solution set. Number 10 is also involving a negative with your coefficient for your variable. Now, what I will show you as a second version to do this problem will be an overkill step for the sake of this problem, but other problems it'll make more sense. Let's do it first the conventional way you'd expect. Let's divide both sides by negative 20 as it's multiplied by x. And here I have x, here I have negative 1/4 if you reduce it, or negative 0.25. But the inequality here also flips because we divided by negative. So this becomes x is less than negative 1/4. Now, I don't do anything very special when I do these. I just write 0, negative 1/4. Remember, the other great thing about placing 0 as a thing other than testing it is you always know that negative numbers are to the left of 0 and positive numbers are to the right of 0. Very easy to figure out where this thing goes. And that's where the x's go. Now here's an alternative way to solve the problem, which again, probably is overkill for this one, but if you have trouble knowing to divide by negatives, you can do this. Although you will be performing another sin of sorts, you are going to be putting your variable on the right side of the equation. So what I could do is I could add 20x to both sides like this, and in turn I'd like to subtract 5 from both sides like that. So now I have them on opposite sides of, this inequality won't change. I have negative 5 on this side, I have a greater than, and I have 20x on this side. So I did that. What this did was that got my variable term positive. Now when I divide by 20, the inequality doesn't have to flip. Now if you're going to those lengths for this kind of problem to do that, just to flip everything over now and bring it back to this, right? If you're doing all of that to get there, by telling yourself, this way I don't have to remember to flip the inequality, well, it's that kind of time you're telling yourself to flip the inequality. So I don't know, I'd say that would probably be a little bit of overkill there. That's kind of one of those trade-off things you have to decide. And normally this wouldn't be more steps. There are other problems where it'll make more sense for me to do it. And if we run into those coming up next, I'll do them. Now we still got to graph this one. Oh, we did. Okay, there it is. Okay, let's jump forward. I'm just going to scroll down here. Let's go to numbers 11 through 13. They say solve the inequality. Oh, is this? Okay, so just a heads up, guys. This picture is not a part of this problem set. I actually did a little manipulation of this quiz thing so the text doesn't look so small. I wanted to make sure it fit the text well, so I had to shrink the images in where it goes. So this image has to do with, I believe, number 14. So please, please, please make sense of that. The PDF down below will not have a reformatted problem set. It'll look normal, and the thing will be wherever it was to begin with. I hope that's okay. So numbers 11 through 13, they say solve the inequality. They don't ask you to graph, although I will be doing 0 double checking as far as what we expect to be true or not, and it's a quick check. I don't have to write anything. So 3y minus 7 is greater than or equal to 17. By the way, this is section number 4, 2.4. So 2.4 is the set where, well, everything's combined as 1, as far as we solve using any steps necessary to get y by itself. I'm going to add 7 to both sides, and I'm going to divide both sides by 3. So both the multiplication or division, addition, subtraction, they're all together now with this thing. Now, they don't ask you to graph, but if I did, we would do anything right of 8, including 8. That means it does not include 0. Does that make sense? What is 0 minus, it's negative 7. Is negative 7 greater than or equal to 17? No. And I didn't expect 0 to work, and it didn't, and that's kind of where we go from it. Remember, 3 times 0 is 0. 0 minus 7 is negative 7. Basically, when I plug in 0, the term goes away to us, right? And that's kind of the cool part about it. Now, numbers 12 and 13 have two different things to say about them. For one, if I substitute 0 into here, the 0 term won't make everything go away. 3 times 0 is 0, but you're still at the negative 2 times 8, things like that. So just keep that in mind. But the other part about this, and because I'm recognizing these problems for what they are now already, you might know what I'm going to say, or you might be able to forecast what this is as well. But I wish they did more problems involving these parentheses where, spoiler alert, where there were solutions, or individualized solving for x, solving for y, solving for g kinds of things. Because what's going to happen here is I'm going to distribute 8. We get 24g minus 16. I distribute 12 here. We get 24g plus 12. Do you see it now? If I subtract 24g from both sides, suddenly no more g's. You're just left with an expression, or an inequality, I should say, that states negative 16 is less than or equal to 12. Now, we've seen this before. This is a special case. It doesn't necessarily mean no solution. In fact, here it doesn't mean no solution. Is negative 16 equal to 12? No. But is it less than 12? Yes. Will it always be less than 12 no matter what you plug in for g? Apparently, because the g's are irrelevant to the problem. They wipe each other out. It's balanced on both sides. This is a true statement. Now, we don't say infinitely many solutions because every problem is infinitely many solutions. So does this one. Any number that's greater than or equal to 8 is true. That's infinitely many. Here we say all real numbers. All real numbers. And this is part of the reason why they probably are not having you graph these. Because what does all real numbers look like on a number line? Well, here's 0 and here's everything. G can be any number in existence, and that doesn't really make sense as a graph. But that means 0 works, and there's no reason to double check 0. Because all you'll probably get is negative 16 is less than or equal to 12. Right? There's just that. Anyway, I wish, like I said, they had one that was just, G is greater than 4, and we can try and plug in 0 into one of these as well. Doesn't look like it's going to happen, because look at number 13. What do you expect number 13's solution type to be? This is me guessing. I don't know if I'm right or not. We'll figure it out. I'm expecting no solution. But that's okay. We probably want that for a quiz review, right? I'm good with that. I just wish there were more questions like 2-4. There were just give me more of these. Not special cases, but less of single step, more of multi-step. If you want more multi-step, obviously go to the section, right? Go to IXL. You have a bunch. All right, distribution of... Now, the reason why they do distribution in problems like these, and I brought this way back up in chapter 1, is they want to disguise the fact that this has the same coefficients on both sides, right? They don't want to show you up front that it is. They want to make you believe that you have to do things to get it right. We'll practice our skills. Now, from here, you probably recognize it. We subtract 12x from both sides, and please do so. Do so and get to the stage where you have just constants down here. Is negative 6 equal to 3? No. Is it greater than 3? No, negative is greater than any positive. No. Neither of these are true. We did all the math correctly, but it just so happens no matter what I substitute for x, including 0, there will never be a solution. This is a no solution case. No solución. Viva la revolución de no solución. Oh. All right. Number 14 uses this photo right here, I suppose. It looks like it has information we need to use. Let me get a water hit, then we'll talk. All right. You probably heard that. 3 requirements for a lifeguard training course are shown. Oh, this is section 2.1 again. In case you wanted to know that we're kind of just coming up with We're not solving, I guess. Write and graph, we'll graph. Write and graph 3 inequalities that represent the requirements. Okay. Now, I might want to use different variables, I assume. You don't want to keep using x each time. Swim at least 100 yards. We'll have that be S for swim. Our swimming needs to be at least 100 yards. That means 100 yards or more. That means 100 is the minimum we must be greater than or equal to. Swim at least 100 yards. This is lifeguard training requirement. That's 300 feet. That's a football field's length. That's a lot. Is this on the daily? What is this? I have no idea. Swim greater than or equal to 100 yards. You could do 1 billion yards. That works. Oh, by the way, this is part A. Tread water for at least 5 minutes. At least is, once again, the phrase. Let's use T for treading water. Treading water must be greater than or equal to 5 minutes. So its own graph. You could probably do it on the same number line if you really wanted to fit things that way. But I'm not in favor. These graphs are not to equal scale. Treading water for greater than or equal to 5 minutes. And swimming 10 yards or more underwater without taking a breath. So there's a difference between swimming and swimming underwater. So in this case, swimming underwater, I'll put a U for underwater. Hey, look, STU. QRSTUV. Hey, that kind of works. I don't know if that was intentional on my end or there. It wasn't intentional on my end. Swim 10 yards or more underwater. 10 yards or more without taking a breath. You take the breath right out of me. So all these are greater than or equal to for those variables. I wish they were going to mix them up a little bit. Part B says you can swim 250 feet, tread water for 6 minutes, and swim 35 feet underwater without taking a breath. Do you satisfy the requirements of the course? Explain. Now, I mean, we know how to do this, you know, even back in like first grade and stuff, right? We're comparing our numbers. But as far as explanation goes, let's compare them to the things that we set up here. Right now, we have an S that's equal to 200. Oh, this is 250 feet. 250 feet. Okay. Now, 250 feet is 1 yard is every 3 feet. So let's do it like the textbook would do a conversion. 1 yard is every 3 feet. Boom. That means we do 250 divided by 3. 250 over 3 is about, what, 83.3 repeating? 250 over 3. 83.3 repeating. So approximately 83.3 yards. Now, when it comes to the first comparison, 83.3 is not greater than or equal to 100. Automatically, we can answer, did we satisfy the requirements? The answer is already no. Now, my explanation is in the math. My explanation is in the math. Comparing, oh, this is supposed to be 100. But let's continue forward. Tread water for 6 minutes. T equals 6, and this is in comparison to the 5. 6 is greater than or equal to, this is substituting for T, 5. That one's good. However, we're still in the no as an overall. The no is, you know, looming larger. It doesn't matter what I'm writing now as comparisons. I'm still just showing you which ones worked, which ones didn't. Swim 35 feet underwater without taking a breath. Now 35 feet, that was U. U equals 35 feet, which is 1 yard every 3 feet. That means we divide 35 by 3. 35 divided by 3 is 11.6 repeating. So I'll say around 11.6 yards. Now we had to be able to be greater than or equal to 10. 11.6 is greater than or equal to 10. That one checks out as well. But the answer is still a resounding no. Despite the fact, okay, my explanation will now be, despite that I show the math there, despite the fact that the, was it treading? Treading and underwater requirements were fulfilled. Swimming for 250 feet did not satisfy the 100-yard requirement. So that's why it's a no. That's why it's a no. Okay. Now it's tricky. It said feet, not yards. All right, 2 more questions. Number 15. The maximum volume of an American white pelican's bill is about 700 cubic inches. A pelican scoops up 100 cubic inches of water. Hold on. Write and solve an inequality that represents the additional volumes the pelican's bill can contain. So they scooped up 100 cubic inches so far. They can get an additional X amounts of cubic inches of water in their bill. I was going to say beak. In their bill. And they can get up to 700 cubic inches. However, they can also have less than. They cannot have more than. So here's the inequality setup for that. When you subtract 100 from both sides, that'll state that we can fit up to, or less than, 600 more cubic inches of water. An albil of volume. Maybe I should have put V for volume instead of X, but that's okay. X represents the amount of volume in there. And that's it for 15. Number 16, and this is another one I had to shrink the image of the bike, but this bike does have important information. It says prices starting at $120. I hope you can see that one. Low price, $120. All right, this is part of sections 2, 3, and 2, 4, so expect some multiplication division and just a mix and match of everything involved. Let's see what we got. Number 16, write and solve, and you save $15 per week to purchase one of the bikes shown. You save $15 per week. Now, prices start at $120. They said write and solve an inequality to find the numbers of weeks you need to save to purchase a bike. I'll make W be the number of weeks. So for part A, if I save $15 per week and multiply that by the number of weeks, this is the amount of money that I save. I need to save it a certain number of weeks in order to match or exceed $120. It needs to be greater than or equal to 120. There's my initial setup. If I divide both sides by 15, 120 thankfully divides evenly by 15, I believe, and you get 8. W is greater than or equal to 8 weeks of time. So you can save up to $1,000. You can buy a bunch of bikes, but you can also save up to 8 weeks, and then you can buy a single bike and be broke again and keep saving up. Part B, your parents give you $65 to help you buy the new bike. How does this affect your answer in part A? Use an inequality to justify your answer. So it's the same setup, only now there's an additional 65 in startup on your end. This means for us, and this is why we do this algebraically, right? I know that you know that if you take the difference of 120 and 65, that's all you got to save. But if you set it up this way, solving algebraically will still get you there. We will subtract 65 on both sides, but our setup gets us going to begin with. That way, more complex problems will be prepared for. That's $55. And now you divide by 15. This does not divide evenly. This is a good time to maybe write the mixed number version because it kind of does mixed number. It's 3, I think it's 3 2/3. 3 2/3 weeks. Now, if you get paid by the end of each week, you might want to do a round up version of that. But I don't know, maybe you get paid just incrementally throughout the week. So within 3 2/3 weeks, you're good. So basically like 3 weeks, 5 days-ish, kind of like that. But so after 3 2/3 weeks, you'd be good. That means that by 3 weeks, you're not good. Even if it was 3 1/10 of a week, 3 1/15, if it has to be greater than or equal to, you don't round down and say, oh, 3.1, 3.01. Oh, that's really close to 3. It's going to round down. No, at the end of 3 weeks, you don't have 120. You may have 119, but not 120. So you need to exceed it. If you had to round up to the next week, you would have to say 4. For here, I'll just say 3 2/3, maybe incremental amounts are good. Now, how does that compare to A? It's reduced. It's reduced compared to you need to save for less time compared to that in part A. That's because your parents came into the clutch. They gave you more than half of what you need. All right, guys, and that is our quiz review. That ought to do it for this one. This is Mr. Robinson. Thanks so much for watching. Again, section 2.4 was really the everything covered kind of portion of this, but in a nutshell of what they did for special cases or their things of multiple, like that last one was kind of a 2-4 question. You had to subtract and then divide. Make sure you still know about the dividing by negatives and such, but for me, it's kind of all a 2-4 review, meaning if you want to jump in straight to 2-4 and get all the practice and you can, I think everything from 2-1 to 2-3 will probably already make sense on its own. So guys, thank you so much. That'll do it for this one. This is Mr. Robinson. Take care, and I'll see you in the next one.